The next transformation is transforming what appears to be a nonlinear equation into a linear equation. Consider a model that looks like this. Beta sub 0, a constant, times beta sub 1 to the power of x. This is a power model. When you see a model like this, you think that this is a nonlinear model. Of course, it is nonlinear model, but we can do some transformation and make it appear as though it is a linear model. So if you take logarithm on both sides, then you get ln of y and then ln of beta sub 0 plus ln of beta sub 1 times x. So now this is like y prime, where y prime stands for ln of y, beta sub 0 prime, that stands for ln of beta sub 0, and beta sub 1 prime, that stands for ln of beta sub 1 times x. So you can fit a linear model like this, and then y hat sub prime will be equal to b sub 0 prime plus b sub 1 prime times x. So once you estimate y hat prime, then we can go back to y hat by simply raising e to the power of y hat prime, and you get y hat. So even though the model is a nonlinear model, we can transform it into a linear model and do the prediction. When would we use this kind of transformation? When this model is appropriate, when the dependent variable y increases as x increases by a percentage, by a proportion instead of a constant value. If you use a linear model, then as x increases, y will increase by exactly the same amount no matter what the x value is. But if it is dependent on the x value, then it will look like that. So let's look at an example now. We have a manufacturing company that makes industrial scales and laboratory equipment. Now they want to estimate sales through the length of employment for the salesperson, how long the salesperson has been around. So dependent variable is number of scales sold. The independent variable is number of months the salesperson has been with the company. So the model is this. Now let's go to Excel and complete the analysis. So here the dependent variable is sales, independent variable is how long the salesperson has been with the company. Okay. So here is y and here is x, and the model is we need to convert y into ln y, and then we keep x as is. So we transform y into ln of y. So ln of y copy that, and then we'll run the regression. Select regression. The y value is the ln of y range, not that. X range is x itself, labels, and let's put the output over here and format. So now the ln of y hat or y hat prime equation is 4.721 plus 0.012x. Now how do we use this equation of prediction? So predict sales for the next period, the salesperson who's been with us for 22 months. So x is 22, use the intercept b sub 0 plus b sub 1 times x. Okay, and remember these are b sub 0 prime and b sub 1 prime. you get y hat prime. So there should be a prime there. Now to get to y hat, then you have to raise e to the power of that, which we can do using the Excel function exp, and that is our prediction. So the same problem, we used the curvilinear model in the first sheet, and there the prediction was 168. Now this one gives an estimate of 146.